Let's work on the following example to find the power absorbed by each element of the circuit. Remember that power absorbed is one that has a positive value, and power supply is the one that has a negative. So let's start with the first element, doing an analysis on this element right here. If we follow the rules, we will look for the terminal that is positive as a point of reference, and then we look down from terminal A to terminal B, and we see that this voltage is positive 8. And the next rule is to check if the current enters this positive terminal. We see that the current actually is exiting the positive terminal, so that means that this is going to have a negative 7 amps like that, and this will give us a negative 56 watts absorbed, or we can say that this is 56 watts supply. Now let's look at the next element, this one right here, and again this will be our point of reference, the positive. When we look from terminal A to terminal B, we see that this is a positive 8 volts, and when we look at the current, we see the current enters the positive terminal. That means that this will have a positive 2 amps, and this will be positive 16 watts absorbed. The next element, we can then write an equation, but first we need to find our point of reference, and this is going to be our point of reference right here. So when we look from the positive to the negative terminal, we find out that this voltage is 12 volts positive. When we then look for the current and try to see if the current enters or exits the positive terminal, we see that the current exits the positive terminal, so this is going to have a minus 5 amps. That will give us a minus 60 watts absorbed, or plus 60 watts supply. Now this value of V sub x, it will be easier if we just look at this as a value of V sub a, where we can see that V sub a then is equal to 12 volts, but V sub a is inside equal to V sub x. So immediately we see that actually V sub x is equal to minus 12 volts. Now let's perform the analysis on this segment of the network. Point of reference. Then we look down from terminal A to terminal B. We see that this has 8 volts. We also check the current. The current enters the positive terminal, so that will be 20 amps. So 20 times 8 is 160 watts absorbed. And finally, the last section of the circuit, where we will find that if this is our point of reference, this will have 20 volts. That now the current flowing into the positive will have a positive sign, and that's going to be 0.25 V sub x. But if you remember, V sub x is minus 12, so this is actually 12 divided by 4 is minus 3, and minus 3 times 20 is minus 60 watts absorbed.